All right, guys. So, lastly, on the topic of linear regression, I wanted to make sure to cover multiple regression. As I mentioned earlier, linear regression is a little bit more of a flexible analysis than your pure correlation coefficient. So, I'll show you a little bit of what that looks like, and additionally, show you the practice problem on creating your regression equation, just so that you can practice a little bit on your own time. So, typically, when you're correlating variables with one another, as we've mentioned, it's not typically going to be the case that variables are perfectly correlated with one another. That's just not really something that's going to happen in the natural world between two distinct variables. So, what that means is if you conceptualize the variance in a single variable as constituting 100% of a pie, the idea is that depending on the strength with which that variable is correlated with one other, represents a chunk of variance in that outcome variable explained. If that amount of variance explained is anywhere south of 100%, it is the case that that variance is from some other source, be it some sort of measurement error or some other variable that additionally would help go towards predicting an outcome variable. So in the example that I referenced earlier, the relationship between study time and a final grade, that relationship was imperfect. It was a strong correlation, but it wasn't perfect, meaning that there was variance left over to be explained. If you're talking about something like grade, it's likely that there are some other variables that go into determining what a student's final grade is going to be. So multiple regression is going to be a process whereby you take into account those other variables, and in doing so, you try and increase your predictive accuracy by taking those other third variables into account. So multiple regression is going to be any time you use a regression analysis with multiple predictor variables to make predictions about a single outcome or criterion variable. Anytime you have a combination of predictor variables or factors, independent variables, that are all going together to generate predictions, you have what's called a model of the relationship between the variables. The idea is you can evaluate various models in terms of how accurate the predictions of the outcome variable are. So let's say if you're trying to increase the accuracy with which you can predict final grade, you know that time spent studying is a determining factor. You know that that has a lot to do with the final grade that someone has. But you might think to yourself that other variables might be relevant as well. Maybe baseline intelligence based on an IQ index, or maybe prior familiarity with the subject. Or maybe you think that a slightly more parsimonious model will do just as well in helping make accurate predictions about what someone's final grade is going to be. You think that, again, time spent studying needs to be in there because you know that has something to do with grade, but you think that IQ doesn't really have that much to do with it, and so prior familiarity will get you to enough prediction accuracy. What you can do with multiple regression is essentially you can run a series of multiple regressions in which you evaluate the predictive accuracy or standard error of the estimate of model A. You do the same for model B, and you see what gets you the best outcome. Now, when I say the best outcome, typically we do want to improve our predictive accuracy, but what we want specifically are variables that have a meaningful amount of variance associated with the outcome. So the idea is that if the standard error of the estimate for model A and model B is essentially the same, maybe adding IQ in explains a teeny tiny bit of variance, the idea is it's still not worth it to include it in your analysis because it appears to not have that much to do with the final grade variable. The purpose here is to determine which variables has a sizable amount of variance that they can explain in the final outcome variable. So what you're going to do is going to be a series of multiple regressions. Again, any multiple regression is any time you have multiple independent variables to predict a single criterion. So you're going to do a series of regressions and figure out between model A and model B, which one do you think works better, which one is more effective, which one is more parsimonious. The idea with multiple regression is that for each model or combination of factors, there's a unique regression equation associated with it. So for model A, since there were 3 hypothetical predictors or independent variables, the idea is that the regression equation is going to have a unique term associated with each one of those independent variables. And there's a unique slope associated with each. So when you see that y predicted equals b1 x1, that would indicate for the first predictor variable, you need to know the slope of that variable in particular, as well as the score on that first variable. Likewise for the second predictor and third. And for each multiple regression equation, there's only a single y-intercept. But there is a unique slope for each one of your predictors. The idea is generating this equation would have you taking a student's study time, familiarity, and IQ and using all of that information to generate your Y predicted value. Now for model B, there were only 2 IVs or predictor variables. So this model would be having you take a student's study time and familiarity and just using that to generate your predictions. Again, you see a unique term on the right side of the equation for each predictor variable and a unique slope with each of those variables. So what you would do essentially to evaluate the models against one another is you can look to the standard error of the estimate for each of these 2 multiple regressions and figure out which one works for you. So if model B has a similar standard error of the estimate to model A or the same, that tells you that IQ probably doesn't have much to do with the variance in grades. That is to say, it probably doesn't do much for you in terms of helping aid the accuracy of your prediction for grades. Again, I'll reiterate that the idea is finding which variables are important or which variables have a meaningful amount of variance that they can explain in your outcome variable. So even if model A was to have maybe a slightly better standard error of the estimate, but not very much, you might conclude that IQ doesn't have enough that it brings to the table that it's really worth including it into the equation. You could just stuff more and more predictor variables into the equation to try and get to a 0 standard error of the estimate. You don't necessarily need to do that. You want to identify which variables are important. So all else being equal, try and think about creating the model that is more parsimonious as opposed to overly complicated or convoluted. Now, if it was the case that model A had an appreciably lower standard error of the estimate than model B, then it would be worth keeping IQ as a predictive factor if you were trying to generate accurate predictions about someone's final grade. So this is what multiple regression allows us to do. It allows you to evaluate different models against each other. Since the numerical outcome in regression that lets you evaluate the strength of your predictions is the standard error of the estimate, that would be a value that you could look at in your analysis to help make this determination. One thing I'll say is that I'm not going to have you guys be doing any multiple regression equations by hand. It just takes forever. You are just going to want to understand theoretically how it works and be able to do those analyses in SPSS, but no handwork for this. It just takes too much time. So one cool thing that you can do using multiple regression is to evaluate a unique way that variables can be interacting with one another that we call mediation. Now, this is going to be conceptually tricky because this is something that is easily confused with the topic of moderation that we learned about earlier. These are 2 distinct topics, and they refer to 2 distinct ways that more than 2 variables can be related to one another. So as I go through explaining this, I'm going to try and highlight how this is not the same thing as moderation. It's a completely different way that variables can be related to one another. Now, mediation, like moderation, is a type of complex correlational relationship. And like moderation, it does explore third factors. But what's critically conceptually different is how the third factor impacts the variables. So whereas moderation is all about a third variable that appears to change in strength or direction the relationship between your first two variables, x and y, mediation, on the other hand, is a third variable that you think helps explain why two variables are predicted. So not that you think the underlying correlation between x and y changes in any way, just that you think you have a third factor that helps you explain why that correlation between x and y is there at all. So you can evaluate this using multiple regression. So this is a process that you're going to be doing in your lab quiz. It's a fairly in-depth analysis, even if you're just doing it in SPSS. Basically, what you can do is you can use a series of individual regression equations and analyses and a multiple regression. You evaluate whether or not all of the statistical outcomes reflect a hypothetical mediation. And then once you have found all those factors are present, you have an indication that mediation may be present. The way this works is that basically you do a series of individual regression analyses to determine whether or not all of the factors in the model, right, the predictor, the outcome, and the mediator, are associated with one another. Essentially, all these factors should be associated, right? You need your variables x and y to be associated with one another. If they're not, there's no relationship to explain. So the first regression is to establish that x is related to y. Now, the next step is to establish that the predictor is associated with the mediator. If the mediator is to have anything to do with explaining why x helps predict the outcome, it needs to be the case that the predictor is associated with the mediator. The mediator, in turn, should be correlated with the outcome. So what you're doing here is a series of individual regressions to establish that x is related to y. The first pathway there you see at the bottom of that triangle. A second regression to assess whether or not your predictor x is correlated or associated with your mediator. That second pathway where the triangle is sloping upwards. And then lastly, your final individual, not multiple regression, a single basic regression between the mediator and the outcome. Okay, so this is all work that is done before you get to the multiple regression piece. Here's where things get really crazy. And this is where some of the confusion between mediation and moderation comes from. What you're going to do next is you're going to run a single multiple regression whereby the predictor x and the mediator are simultaneously included as independent variables in the regression, both simultaneously predicting the outcome. What's interestingly going to happen by virtue of the analysis is that the relationship between the first predictor factor x and the outcome y will drop to non-significant. Now, here's what you have to keep in mind. This is why I believe students often think that mediation and moderation is the same. When the relationship between the predictor x and the outcome y drops to non-significant in the context of the multiple regression, the relationship between x and y is not actually changing in a real sense. The relationship is still there. X is still related to y. You haven't actually changed the data. What changes is what the regression is telling you about the mediators explaining why x is related to the outcome. So when the mediator is included in the model, the idea is that the mediator helps explain the variance that variables x and y share. So what the analysis demonstrates is that the mediator appears to be explaining that underlying relationship. Again, I'll reiterate, it's not like moderation where that underlying correlation is changing in strength or direction, despite the fact that that relationship drops non-significant. That's just the regression telling you that the mediator is a go-between. It acts as a sort of explanatory pathway that helps tell you why x helps predict the outcome. Okay, so this again is different from moderation. I'll show you some examples of mediation and of moderation, but this is the critical difference between moderation and mediation, and this is where some of the confusion comes in. Mediation is not where the third variable changes the underlying correlation. It's when you're trying to explain why there is an underlying correlation in the first place. So that relationship dropping to non-significant is just a function of the regression helping you explain something. So a good indication that you may be thinking mediation is going to be this classic triangular visualization. So this is different from your moderation visualizations where you had levels of the moderator showing different strengths of correlation between your first two variables. If you're trying to depict mediation, much more often you're going to see a depiction like this. You're going to see your first two variables being at the bottom of a triangle, right? So in this case, the example depicted here of early childhood physical abuse leading to violent behavior, right? That would be the underlying correlation that you're seeking to explain. What is it that happens after early childhood abuse that leads to violent behavior? If you're thinking mediation, the idea is that you're trying to think to yourself, what does early childhood abuse do to people that then in turn produces violent behavior? You're theorizing that there might be a go-between, that it's not that the abuse goes straight to the violent behavior, but that there's a series of things that happen in between that helps get you from X to Y. Okay, so a good indication that your depiction is mediation or maybe mediation is you're going to be thinking this triangular graphical presentation. And your first two variables should be at the bottom of the triangle. The first correlation that you're trying to explain is going to be the bottom, and whatever your proposed mediator is should be at the top of that triangle. This is a graphic that indicates that you're conceptualizing that variable at the top of the triangle as the explanatory go-between or mechanism that helps get you from the first variable to the outcome. Okay, again, the mediator is meant to be a variable that helps explain a relationship between a predictor and an outcome. Okay, so you might say that depression leads to weight loss. That's a pretty strong relationship. But what is it about depression that leads to weight loss? It would make sense that that relationship is complex enough that you think there might be some go-betweens or some mechanisms, right? You might say to yourself, depression leads to increases in stress. Stress more proximally causes people to lose weight. So the idea is, you know, there's a relationship between depression and weight. You're not predicting that that relationship goes away or changes depending on levels of a moderator. You're saying that you think you can help explain why depression leads to weight loss. You're predicting because it's via the mechanism of increased stress. So then I'll show you an example from some real life nostalgia research from some colleagues of mine. This research on nostalgia was interested on the social implications of feeling nostalgic. Whereas nostalgia used to be considered a sort of an unhealthy living in the past sort of a phenomenon, plenty of research has indicated that it's a pretty positive psychological experience. So in the research by my colleagues Dr. Abeda and Dr. Rutledge, they established that boosting nostalgia tended to be associated with positive social outcomes like desire to make new friends. You might think to yourself, what about nostalgia makes people want to go out and make new friends? It seems weird enough that you might want to further try and explain why there is a relationship between nostalgia and wanting to make new friends. So it's thinking about, why is that relationship there? Is there a go-between? Is there another variable that can help me explain where that relationship came from? Okay, so the research is linked here. Essentially, they first demonstrated in some studies earlier in the paper that nostalgia was positively associated with relationship goals, and they measured this a variety of different ways. They also found that nostalgia was positively associated with a factor of social confidence. So Priming people with nostalgia made them feel a little bit more secure and confident that they could go out and successfully have social interactions. Think about it. If you're becoming nostalgic, you're likely thinking about cherished memories with loved ones. It's reminding you of all the times that you've had positive social experiences. So it makes sense, I think, that a little bit more directly, nostalgia is going to boost that confidence factor. So then they further asked whether this social confidence boost was helping to explain how you go from nostalgia to social goals. So, this is what their analyses looked like. It's the same series of regressions that I alluded to earlier. So, first, they needed to establish that there was this relationship between nostalgia and the relationship goals. They did that. Afterwards, they needed to establish that the first predictor of nostalgia was associated with social confidence, and it was. Lastly, this third pathway needed to be significant of social confidence relating to the relationship goals, in this case, intentions to resolve conflict. So these are all the factors that preliminarily may indicate that it's possible that a mediation is present, but critically, you need to do that final multiple regression in which nostalgia and social confidence are simultaneously in the multiple regression at the same time going to predict this intentions to resolve conflict. Once you do that multiple regression, that pathway from nostalgia to intentions should drop to non-significant. As I showed you earlier, when you do your regression analyses, there is an output at the bottom that shows you the significance value of a particular predictor. So that's where you would look to see whether or not this has occurred. So this is what regression is good for. It lets you evaluate some particular kinds of more complex correlations, including being one way that people can analyze for mediation. Okay? So in asking yourself whether or not you may be conceptualizing or properly thinking of an example of a mediation, always make sure that your explanation is about explaining via a third variable why there is a relationship between your first two variables. And so think of a graphic that uses this triangular formation. It's not like the graphics you created for moderation. Think this triangular format, and your proposed mediator should be at that narrowest end of the triangle. Ask questions like, why is there a correlation between my first two variables? And in this case, it's the why question that represents your third variable. Analysis, though, can be done with a series of regressions. Again, you're not going to have to do this one by hand. You're just going to want to be able to understand and analyze the output that you get with a multiple regression. Okay, so again, just to make sure that the distinction between moderation and mediation is clear, here were some visuals of moderation that we saw, right? Again, moderation is about a third variable that changes the underlying correlation. So like this one that I showed you, where there's a relationship between stress and depression, but the strength of that correlation changes depending on level of social support. So moderation is about that underlying relationship between stress and depression changing. If you're thinking mediation, you likely have something that looks like this triangular looking thing. The mediation should look more like this because the first two variables that are correlated at the bottom of the triangle or at the widest end of the triangle, right? Math ability to interest in the math major, right? You need to establish that that underlying correlation is there. The idea, again, is not that you're predicting that that relationship between math ability and interest changes depending on levels of the mediation, despite the fact that you see that p-value change. You are not saying you think that that underlying correlation is going to go away or be diminished at levels of the mediation. It's that you think you can explain that correlation. So, for example, in this visual, math ability is related to interest in the math major. Well, it appears to be the case that math ability seems to boost what we call your self-efficacy or your belief that you can accomplish something. And it's this boosted belief in your own abilities that in turn appears to more proximally be associated with that interest in the math major. So a quick and dirty understanding of moderation versus mediation is going to be Moderation is going to look more like the visual on the left, and mediation is going to look more like the one on the right. But make sure you're thinking about why these two graphics show two distinct kinds of complex correlation. Okay, so mediation, be thinking this triangular format. Okay, think through what's a correlation that I know exists that I don't necessarily think will change depending on level of a third variable, but that I think can help explain why that first set of variables was related. So think triangles. Okay, so now I just have the basic practice problem that we would do in class. So I guess if you'd like to do the practice problem, then you could just pause this video once I stop talking, give yourself some time to work on it. Essentially, what I would have you guys do is create the regression equation that defines this relationship between nostalgia and happiness. This was actually that same Pearson's R correlation coefficient we computed in a lecture back when we were learning about correlation. So if you actually are able to revisit your notes and find the handwork that you did for this correlation between nostalgia and happiness, you can actually use that same work to start to begin to work on this computation for regression. So if you do need to get that work, if you do need to go find it, that certainly make this take not as much time. Okay. So in creating the regression equation that defines this set of data, right, you need to create the components that help you define the best fit line, the slope, and the y-intercept. So these are your equations to do that. You need to start with your slope. Again, like I mentioned, if you have your work handy from when you computed this Pearson's R, you have all of that stuff in your notes somewhere, and you just need to retool them to compute your slope for this particular equation. And then once you have the slope, you compute your y-intercept. Then from there, you just put them together into your fully formed regression equation. Right, so your notes from when you did the Pearson's R hopefully look a little bit something like this. You just need to know which pieces to pull out in order to do your regression equation computation. Okay, you need to get your x, y terms and your x squared. You don't need y squared here. That's not in the slope equation. But all the rest of these terms, you need those to compute your slope. Then from there, you just solve it down until you get your slope. Again, there's no range that slopes are necessarily going to be within the boundaries of. A slope can be any numerical value, really. But what you should be able to tell is whether or not the direction, at least, of the slope was correct. So we knew that that was a positive correlation, so the slope would necessarily be positive as well. So that b value represents the slope of your equation. Then from there, you need to get the mean of y and the mean of x, y bar and x bar, in order to compute your y-intercept, as well as your slope. Solve that to get your y-intercept. Again, there's no numerical scale that restricts what value your y-intercept can be, but again, if you just create your scatter plot on scratch paper and draw the best fit line sort of by eyeballing it, you would be able to at least get a rough estimate if you tried your best to draw to scale of whereabouts that y-intercept should be falling. So you can't correct yourself to a high degree of specificity, but you can make sure that you're in the ballpark. And then from there, you would create your regression equation, and it would look like this. So then if I was to give you any score of x, I think in this case it was nostalgia, from there you could compute any predicted happiness score. So that's all I have to say about that. So then lastly, I'll show how you check your work in SPSS. Again, as with correlations in SPSS, you need to have a line for each of your individuals with their unique x score and their unique y score. And then here would be your regression output. Your model summary bit, again, the same R that we computed way back a million years ago when we were still in face-to-face instruction. That R value is the same because this is essentially just a bivariate analysis. And that standard error of the estimate reflects that this is a pretty strong relationship as well. So you do look to that model summary area of the output to evaluate the strength of the correlation, but to check your work on the regression equation itself, you look over here. Again, that value in the row labeled constant over in the B column in the unstandardized coefficient area to the left. That value in the constant row, that is your y-intercept. Even if you're doing a multiple regression, in that case, all of your predictor or independent variables would be listed downwards underneath that model label. The value at the top in the constant row, there'll only ever be one of those, and it will be the y-intercept for your equation. Again, recall that even if you're doing a multiple regression, there's a single y-intercept for that unique regression equation. And then in the row labeled with the predictor we're currently contemplating, the value in the B column there in that row, that 0.745, that's your slope. Again, if you have a multiple regression, you're going to have multiple variables listed downwards underneath the model label. Whatever value is in that row is the slope for that labeled variable. Okay. Here's some pictures of Jade because that was a lot. I hope you guys are staying alive, staying healthy. This sucks. I wish we could go back, and I miss seeing you guys in class. And just, I hope we all stay, healthy and sane because this kind of blows. You know what I'm saying? All right, I'll see you guys when I see you.